Hello everyone, this is Ashwin here. In this video, we are going to see about how to create an image caption generator using Flickr Dataset. So this is a deep learning project. I am going to use keras with TensorFlow as a tech stack in this project. The objective is to build a image captioning generator. So we will have a random image and our model will see the image and give us some captions. Let's say we have an image, a boy is walking means the model will extract the features from the image and try to generate the caption like a boy is walking or running, similar to that. So that is the objective of this project. So we will be using both CNN for image feature extraction and LSTM for natural language processing. So we'll be doing a lot of pre-processing steps for both image and text data. Now, without further ado, let's start the project. First, let's import the modules. Now, import modules, and this session is enabled with the GPU. So we need a GPU for faster processing of image data. Now, let's import the basic modules. We don't need pandas here because I'm going to get the data from this Kaggle, so we just need the images and the text, so it will be easy. Apart from that, we will import all the other basic modules. So import OS, import pickle. OS is for handling the files, pickle is for storing some numpy features. Let's say if we are extracting image features, means we have to store it somewhere, or else we have to redo the entire process again. And numpy, that is our basic module for every project. And apart from that, we have tqdm dot notebook, import tqdm. Okay, this is tqdm. Okay, this is for giving us a UI for how much data is processed till now. So it will be very helpful for getting an estimation of the overall process. Now we are going to import a lot of TensorFlow and keras modules. I'm going to use from TensorFlow dot keras dot applications dot vgg16. This is for extracting the features from the image data. So vgg16 import vgg16 and preprocess input. So this is for preprocessing the image data for the VGG. So we have to do the preprocessing corresponding to the model we are going to use. And I'm using tensorflow.keras because it's not showing any error. Sometimes in the recent version of keras, it's showing some error for importing of modules. So that's why currently this is like a better way of doing. So that's why I'm doing like this. And next, again we will import some pre-processing. tensorflow.keras.preprocessing dot image, import load image and image to array. And apart from that, we have to pre-process the text. So for that, from tensorflow dot keras dot preprocessing dot text, import tokenizer. Okay, and again we have to copy the whole thing. Now instead of text, we will use sequence dot pad sequence. So for pad sequence means it will even out the whole text representation of features. Let's say some sentence have 10 words and some are in 5 to 6 words, means we have to even out. That's why we will be using a pad sequence in order to fill out with zeros for the remaining length. And after this, we will be having again paste it instead of pre-processing. I will just say models, import model. Okay, and other than that, we need to import some utilities. So for that, utils, import to categorical and plot model. So this will give us a clear representation of the whole model in terms of an image. So it will be easy to see the architecture of our model. Now after this, we need to import only one thing, that are the layers. So from tensorflow.keras.layers import input dense LSTM embedding dropout and add. So these are the modules I am going to import. And this, okay, I just made a mistake here. Again, run this. Now we have imported all the modules. Now we have to set the base directory and working directory. So for that, base underscore directory equals kaggle slash input slash Flickr 8K. So this is the kaggle directory currently we are in. That is this directory. After that, we will concatenate this subfolders in order to get the data. And apart from that, we will have working directory. Working directory equals kaggle slash working. That's it. So it will be easy to access files using this variables. Now I'm going to extract image features. So extract image features. So here load VGG16 model. So for that, model equals VGG16 off, and we have to restructure the model. So restructure the model. So again, model equals model of inputs equals model dot inputs. So this is the image input we are talking, and outputs equals model dot layers of -2 dot output. So what we are doing here is we don't need the fully connected layer of this VGG16 model. We just only need the previous layers in order to extract the feature results. So that's why I'm just leaving the last layer and getting the before layer output and assigning it to outputs. So this will be our restructured model. And after that, we will summarize. So summarize print model dot summary. Run this. Now it's downloading the weights, and here you can see. So here we are leaving one layer. Let's say I'm getting the last layer, means see here we are leaving out this predictions layer. We don't need this. We just need this feature extraction part alone. So that's why I'm just leaving that layer. Now run this. So this is our model we are going to use in order to extract features from the image. Now that's done. Now here extract features from image. So here I'm going to create a dictionary. So in order to have a key value pair, key will be the image ID and the value is the features. So features equals a dictionary. Now we have to get the directory for the images. So I will say directory equals os dot path dot join of base directory comma images. So this is the directory contains all the images. Now we are going to iterate through the images for image name in tqdm of os dot list dir of the directory. Now we will be getting each image name. Now load the image from file. I will call it as file name equals directory plus slash plus image name. You can also use this os.path.join. Both will give the same results. Now I'm just concatenating the image name. So in order to get the whole file path, you can say it as file path itself, or it will be appropriate if we call it as image path. Now let's load the image. So image equals load image of image path comma target size equals 224 comma 224. So this is the dimensions of width and height I am setting. So it will be resizing the image and after that it will be loaded. Now we will be converting the image pixel to a numpy array. So convert image pixels to numpy array. So that will be image equals image to array of the image we have to pass. Now we have to reshape the data for the model in order to extract the features. Reshape data for model. I will say image equals image dot reshape of 1 comma image dot shape of 0, image dot shape of 1, and lastly image dot shape of 2. So this is the shape. We are going to resize it. This is a RGB image, that's why we are having 3 dimensions, and this is like a single sample. Now let's prepare the image for the VGG model. So preprocess image for VGG. Now I'll say image equals preprocess input of image. Now that's done. Let's extract the features. Extract features. I will say feature equals model dot predict of image comma verbose equals 0. So it won't display some status or some additional text. So it will be clean. Now after extracting the features, we will get the image ID. So get image ID. So image ID equals image name dot split. I'm just splitting it by dot because if I show you here, so this is the complete image name. As you can able to see, if we split it by dot means we can remove that JPG. We just need the 0th index. So I will have the 0th index in order to get the image ID. So these numbers are the image ID. So when everything is done, store feature. So that will be features of image ID equals feature. So I think that's pretty much it. It will extract features for all the image that is present in our data set. This would take some time. Okay, tuple object is not callable. Okay, this is an array. I just mention it as like a tuple. Again, run this. Okay, now it started processing. Now you can see we have around 8K images. That is the Flickr 8K dataset, and it has to extract for all the images, and we are getting around 15 iterations per second. If you use only CPU, means it will be 1 or 2 images. That's why you definitely have to go with the GPU, as you can able to see here. So this will take a longer time. In the meantime, we will complete the remaining things. Let's say if you are extracted the features, means you don't want to lose the features again, or else you have to re-extract it. So it will take a long time. So I can store it in a file. Store features in pickle. So pickle dot dump of, I'm going to dump this features dictionary, open of os dot path dot join of working directory. Okay, working underscore dir, and here I'll specify the file name. I will call it as features dot pickle, and I have to pass the argument as wb, that is write binary. So this will dump your dictionary into a pickle, and you can reload it again using another snippet. I'll show you here. Load features from pickle. So this will definitely save your time. Make sure you do this for all of your deep learning models, because this will save a ton of time for you. Now with open as again the same os dot path dot join everything as read binary. So that is the format we are going to read as file. Now again features equals pickle dot load of f. So this will reload all the features from the pickle file. So this is the syntax for storing data in the pickle and again reloading from the file. Now that's done. We will use this after this completes. Next, we have to load the captions. So here, load the captions data. Now again with open as again os.path.join. Here instead of features.pickle, we will say captions.text, and instead of working directory, we will use the base directory, and we have to set the read option and as f. Now next of f, I'll tell you why I am using next. So let's close this. Let's open this caption. So here in this text file, we do have image comma caption. We don't need this first line. That's why I'm using next here. So it will skip those line, and we can proceed further. Now I will say caption doc equals f dot read. So it will just read the whole text data. So that's done. So we just have to wait until this completes. It's still halfway done. Now, similar to what we have done for the features, like for each image ID, we do have the corresponding feature, right? We are going to do the similar process for the caption. For each image ID, we'll be having the corresponding caption. So I will say create mapping of image to captions. Now for this, I'm going to create a dictionary called mapping equals a dictionary. Now we are going to process the lines, for line in tqdm of captions doc. Okay, I didn't load it yet. So caption doc dot split of a new line. I'm just taking line by line. So \n. So this will split it and take line by line. So now we are having like a first line, it will contain the image and the caption. So I'm going to split the line by comma. So I'll say tokens equals line dot split of comma. So tokens of 0 will be the image ID and tokens of 1 will be the caption. Now if len of line less than 2, continue. Let's say if we have some lines with some only single letter or something like that, that may be an error. In order to avoid that, we can have this statement. If your caption files is good, means you don't need this. This is like an optional one. So now we are going to split it. So image ID comma caption equals tokens of 0, that will be the image ID, tokens of 1, that will be the caption. Now we have to remove extension from the image ID that will have that JPG. So here remove extension from image ID. Now image ID equals image ID dot split of dot of 0. This we already done it before. And also if we have multiple tokens, let's say in the captions, we are splitting it by this, right? So this will be like a set of string. We have to specify one colon. So this will get it from first index and the rest of them. After that, we will convert this list into a string. Convert caption list to string. I think the feature extraction is done. Now store the pickle. Let's see if it is done. See, this file you can download it and reuse it again. So it will be easier. If you want, you can run this and reload it again. I'll just leave it as it is. Now run the captions. So we will have the captions doc. Let's also double check. So captions doc. So this is the text data we are having. We are splitting it by n. Okay, this is a big one. I think I can delete that. So I am splitting it by n. So we will be getting line by line, and after that here where we left off, convert caption list to string. So that will be caption equals dot join of caption. Now that's done. After that, a image can have multiple captions. Again, I'll show you. So here these are all same image name, but that will have multiple caption. We are going to store all the captions in a list, so it will be easy for us to do the mapping and pre-processing. So create list if needed, if image id not in mapping, then mapping of image id equals a list. So if the list is already there for this corresponding image id, means we just have to append it. Again, mapping dot, okay, sorry, mapping of image id dot append caption. Store the caption. So that's done. This will be taking, now let's run this. Okay, that's loaded very quickly. Now let's see how many images we are having. Len of mapping. So we do have all the 8K images. So that's done. Now we have to pre-process the captions. So for that I'm going to create a function called clean. So def clean of mapping. So for key comma captions in mapping dot items. So we are going to pass this mapping as an argument, and I am going to iterate the key, that is the image, and the corresponding captions. Now again, for I in range of len of captions, caption equals captions of I. I'm just taking one caption at a time. Take one caption at a time. Now let's do the pre-processing. Pre-processing steps, and I can call this pre-process text data. Pre-process text data. Now for the pre-processing steps, we'll have caption equals caption dot lower. Now after that, caption equals caption dot replace of. I'm going to pass some regex, so that will be except A to Z. I think you don't have to mention capital, but this is like a standard way. If you didn't use the lower, means you need to mention this. And after that, small a to z. So except the characters in the alphabet, we are going to remove everything. So that's done. I'm just converting everything to a lowercase and removing all the digits, special characters. So this is a one line pre-processing step. After that, caption equals caption dot replace backslash s plus. If we have multiple spaces, means we will be using this. I am just replace it with a single space. I'll also mention this, convert to lowercase, replace digits, special characters with we're not replacing, we'll just delete digits, special characters, etc. And after that, delete additional spaces. Now that's done. And the last pre-process step is for our model. So usually we will do this for the sequence to sequence models. Add start and end tags to the caption. So that will be caption equals, I'm going to add start. So this represents like a starting tag, and after that we will have a space, we will have our caption plus, and again we will have a space, end. So this is the starting tag and this is the ending tag. So it will be very helpful for the model when to start and when to end. So this will help us to stop the prediction. If we got this end tag, means we will just stop it. That's how it works. Now here in the caption, I'm also going to remove some words with less number of characters like a, s, and some small words. Now I'm going to remove single characters from the caption. Let's say a little girl is walking, means I'll just remove that e. We don't need that smaller words. So instead of having the caption, we will have space dot join of a list word for word in caption dot split. I'm just splitting it by space. Now we will say check for the condition len of word is greater than 1. So if it is greater than 1, means we will take that word and concatenate as a string, and we will also add this into the string for the starting and end tag. So after doing this, we will have captions of I equals caption. Again we are just replacing the caption at the corresponding index. So this is the function for doing the pre-processing. Let's run this. Now for our example, we will take one mapping. So that is before pre-process. So I'll call it as before pre-process of text. I'll say mapping of, I need one image ID. So I'll go to the captions, I'll take the first image ID and paste it here. Let's run this. So this is the captions we are having for this corresponding image. Now pre-process the text. I'm going to call the clean function with the mapping. So that's done. Now let's see after pre-process. I'll again copy and paste this of text. This is not pro-process, this is pre-process. Sometimes the spelling mistakes are happening. Okay, now you can see the pre-processed text. We don't see any special characters. We are not seeing any single letters here in this EA and all. It's removed, and we do have the start tag and the end tag. So it will be easier for us to do the further processing. So this is the pre-process of text data. So that's done. Now after this, we are going to create a tokenizer and create a vocab size. So we will be using this tokenizer for getting the index of that corresponding word. So this will be very helpful for using in the model. Let's say all captions. I'm going to store all the caption in a single list. So that is all captions. Now for key in mapping, for caption in mapping of key. You can say mapping or mapping dot keys, both are same. I'll say all captions dot append of caption. So this will be a full list or the entire list of captions that are available. Run this. It's quick. So that's done. I'll check the length of the captions just to get an idea what we are dealing with. So we have around 40,000 unique captions. That is like around 5 captions for each image. So that's good. Now we will check the first 10 captions. So all captions of 10. So this is the first 10 captions we are having. So just for an example. Now let's start the processing. So tokenize the text. Now here I'm going to initialize tokenizer of. Now tokenizer dot fit on text. I'll pass the all captions, and we will be getting some vocabulary size. Vocab size equals len of tokenizer dot word index, that is the total number of unique words we are having, word index plus 1. Run this. Now let's check the vocab size. Vocab size. So we are having around 1483. That's good. And in the next part, we have to get the maximum length of the caption. So here, get maximum length of the caption available. So this will be useful for padding the sequence and creation of the model. So it will be helpful for us. I will call it as max length. Max length equals max of len of caption dot split. So here for caption in all captions. So this will be getting the max length. Now let's display it. So the maximum length for the caption is like 35. So we are going to use this variable for padding sequence, and even in the model we'll be using. So now that's done. Let's create a markdown for train test split. Train test split. We have around 8,000 images. We can usually process these images if you do have a big capacity of RAM. Currently, if you go into the Kaggle means, we are having around 13 GB of RAM. So when I ran without any kind of data generator or without splitting the data, the session will be crashed. So what I'm going to do is I'm going to create a separate function for taking inputs one by one, so it won't be crashing. So this will be very helpful for you. And if you do have a large capacity of memory means you don't have to do this. So it will be simpler for you. And yeah, let's do that. First, we will split the train and test data. I will get the image IDs. Image IDs equals list of mapping dot keys. So this will have the image IDs. And after that, we need to have a split ratio. So split equals int of len of image IDs. I'm going to get only 90% as training data. So 0.90 Let's see the split. So 7289 will be used for training and the remaining will be used for testing. Now I'll say train equals image IDs of colon split and test equals image IDs dot of split colon. So this is the train test split. Run this. Okay, that's done. Okay, now we are going to create a data generator in order to fetch the image and caption like in batch size. So it will be easy for us to load into the model and train it, or else it will load into the memory and mostly your session will be crashed. So this will be helpful for the users who have less than 16 GB of memory. So if you have around 32 gigs of memory means you don't have to do this. Now I'll just have it as note, create data generator to get data in batch, avoid session crash, avoids. Okay, now def data generator of, we have to pass multiple parameters here. First I'm going to pass the data keys, that will be the image IDs, mapping, features, tokenizer, max length, ocap size, batch size. So using this we are going to do a lot of processing here. We are also going to do some pre-processing like padding of sequence here. Let's see. Here loop over images. Now I'll create a list. So that will be x1, x2, y equals list, list and a list. Everything will be an empty list. So now n equals 0. So this is useful for determining whether we reach the batch size or not. Now while 1, this is an infinite loop, for key in data keys. So data keys will probably this train, that will be the image IDs of the training. Now when we get a new data, I will increment n plus 1 and after that I will get the captions equals mapping of key. Now we got the captions. Now for caption and captions, I'm taking each caption, process each caption. Now I will encode the sequence, encode the sequence. So sequence equals tokenizer, yep, tokenizer dot text to sequence. Is it suggesting or not? Text to sequences of. In a list, I'm going to pass this single caption and I will take 0. So this encoding means for each word we'll be assigning the index. So we'll be getting a list of sequence index, and after that I'm going to split the sequence into x, y pairs. So this means x is the input, y is the output. So I'll explain what this step going to happen. So now I will explain how the process gonna happen. I'll have a string. I'll have some example string. Okay, this is the smaller one. I'll just copy this, paste it here. So this is the sequence we are having. So what our objective is to get the input and the output. So for each sequence, we'll be getting, this is X and space, this will be Y. I'll also have the space. Now first in the input, I will have only the start sequence. So based on the start sequence, and after that we will be getting this girl. So that is the output we are going to predict. So Y will be girl. And after this, we'll be having the start space girl and the next word as the output, that is going. And after that again, start girl going space into. So this is how the sequence flow works. First, initially we will be having only the starting sequence. So using this text sequence and the corresponding image sequence, we are going to predict the next word. So that is the girl. And after that, we will concatenate both input and output, have it as a next input sequence. So this is the next input sequence. And again, we are going to predict the next word, going. And again, we are going to concatenate everything. So girl going, and we are going to predict into. So this process will go on. This process will go on. Finally, when we have the last prediction, that is the end, when we have this, we will stop the prediction. So we will be having girl going into wooden building. So that is our answer. So that's how the whole sequence splitting works. Now let's do that for I in range of 1 comma len of sequence. Now split into input and output pairs. So in sequence comma out sequence equals sequence of colon I. First we are going to get only one word, that is the start, and after that we will get the next sequence of I, that is this word, that is the next word. Let's say if we have I as 1 means the girl will be the sequence of I. So that is the output. And the process keeps on going until the end of the sequence. So this is the in and out sequence. Now we have to pad the input sequence because we need to have a common length. So pad input sequence equals input sequence equals pad sequence of in a list, pass the input sequence, comma max length equals max length. And here also we'll be getting that 0th index. There will be additional results, that's why we just need to get this 0th index in order to get our padded sequence values. If you want, you can also print in between to see the intermediate results, so you will get an idea what's apart from the output is there. And we will encode the output sequence. So encode output sequence, this is like a one hot encoding. So output sequence equals to categorical of the output sequence, comma number of classes, that will be the vocab size. Here also we'll be getting the 0. So why we are using 0? Because we are passing this as a list, so it also return a list of pad sequences. When you pass multiple sequences, let's say this is in sequence 1, in sequence 2, like that, if you have multiple sentences means it will give you a list of padded sequence. So we are just passing one, that's why we have to get only one. So that's why we are having all these zeros here. You can also, as I said before, you can just print it and see. So this categorical will be converting this output sequence into a one hot encoding. So if the word is present means it will be represented as 1, and that's done. So we have like a lot of classes. I think it's around 8,000. So we'll be having like 8,000 columns. After this, we will store the sequences. So I will have it as x1 dot append. So this will be the features, that is the image features of key of 0. Now x2 dot append. So here we will have the input sequence. So we'll be having two inputs, that is one is image features and the second one is the text feature, and output will be out sequence. So this is done. This is the whole step. Now outside this, if n equals batch size, if we process some particular number of samples means, we will say x1 equals np dot array. We are just converting into array because the model can process the normal list, that's why. And again we will convert this also. We can do this in a single line, that will be much easier. So x1 comma x2 comma y, and here np dot array of x2 and np dot array of y. So that's done. After that, yield. So this will return the collected samples to the generators. So this will be consumed by the model. So I will have it as a list x1 comma x2. This is the two inputs we are having and the output. After this we have to reinitialize because we don't need that, or else we will exhaust the memory. Equals again the same initialization part, and here again we have to set the n as 0. So that's done. So this is the whole data generator part. Because of this padding sequence, so we are just doing it inside the data generator, so it will be clean for us. And I guess that's pretty much it. You can track over each input in order to understand very clearly. Currently it's we are not going to display anything because everything is in the function. So we are going to get these results for the model to consume. Speak about the model, we have to create one. Okay, let's run this. Here, model creation. Okay, now we will be concatenating two features and going to create a model, and we will plot the model so we can able to clearly see how the model looks like. So inputs 1 equals input of shape of 4096. So this is the shape of the features we are going to get. If you see the VGG model output, you can see the output is like 4096 that we are going to consume here. So that will be the input, and we'll be having a feature 1 equals dropout of, I will have it as 0.4, and I will pass this inputs 1, and fe2 equals dense of 256 comma activation Okay, activation equals relu, and here I am going to pass this fv1. So this is the input we are passing, and this is the output we are getting, and again we are passing this as input, and this is the output we are getting. So this is for the encoder model, image feature model, and after that I will have sequence feature, I will say layers, that will be better, layers. Here I am going to have inputs to input of, again shape equals of max length. I already told you max length will be helpful for us. Now we will have se1 equals embedding of ocap size comma 256 comma mask 0. It's not suggesting, so mask 0 equals true because we are padding the sequences, right? That's why we have to set it as mask 0. So this is just the dimensions of the input based on the ocap size, and we will be passing inputs to, and se2 equals dropout of 0.4. You can set it as 0.425, so that will be better, so that will avoid overfitting. Now that's done, and again we need to have a LSTM layer. So se3 equals LSTM of 256 of se2. So this is the sequence layers. So all these considered as like a encoder model, and after this we'll be having decoder model. Here we are going to concatenate both this image and the text features. So decoder 1 equals add of a list fe2 comma se3. So I'm just concatenating the features. Decoder 2 equals dense of 256 comma activation equals relu, pass the decoder input, decoder of 1. That's done. Finally we'll be having the outputs equals again dense of ocap size. I already told you we have converted into like a categorical vocabulary, and activation equals softmax. This will be used for categorical variables, and decoder 2, that is the input for this output, and that's done. Now the last step will be model equals model of inputs equals inputs 1 comma inputs 2 comma outputs equals outputs. So for this model we are going to have 2 inputs and 1 output. After that we have to set the loss and optimizer. So model.compile of loss equals categorical underscore cross entropy optimizer equals Adam. That's done. Finally plot the model. So this will give us an image. So plot model comma show shape equals true. You can also save this as an image, that is also possible. Let's run this. Show shapes and this. Okay, now we got the model. So currently this is for the image. As you can able to see, we have an input layer, dropout layer, and the dense layer. Here this is for the text, input layer embedding, and the dropout with the LSTM. And we are just concatenating both of these things into a single dense layer, and we are going to process it. And this is the 8483. This is the categorical one hot encoding we have done. So that is the output. If the word have higher probability means that word we are going to get. So like that we are going to process it. And here we already extracted the features. That's why we didn't use CNN, or else we would have used some CNN model in order to extract the image instead of VGG. So that is also possible. So we will be having like CNN LSTM concatenation. So that's done. Let's train the model. Train the model. If you didn't use the data generator means it will train quickly, but it will take up a lot of RAM. But if you use data generator means you don't need that much RAM, but the training process will take some time. So I will have epochs equals 15. You can increase the output score by increasing the epochs, because this needs a lot of time to train. I will set the batch size as 64. That's a reasonable amount. Now steps equals len of train divided by batch size. Step means after each step it will do the back propagation and fetch the next data. So for that only we are using for I in range of epochs. Now create data generator. Now I will call it as generator equals data generator that we have created before. I will pass the training, mapping, features, tokenizer, max length, vocab size, finally the batch size. Okay, we got the generator. Now we are going to fit for one epoch. So model dot fit of generator. So you from the generator will be getting the inputs, that is x1, x2, and the y. I will set the epochs equals 1. Steps per epoch equals the steps we have found here, and finally verbose equals 1. So this won't show you any validation accuracy, because we don't have any validation generator. So we will do the testing and validation after training the model. And after this you can also save the model if you want. So currently I am gonna run this. So this will take a lot of time. As you can able to see, for each epoch it takes around like 1 minute. So we have to wait for 15 epochs. Let's wait. If you want to save the model afterwards means you can say model.save. I will say best model dot h5. Okay, using this you can save the model. I can command this, save the model. So that's done. Now we can come back again after the training completes. we need to create some few more functions for predicting the captions from the test image, and we will also plot the image and the corresponding actual caption and the predicted caption, so it will be helpful for us. So welcome back, guys. So we have completed our training with the 15 epochs. As you can able to see, the loss has been decreased significantly. You can train further if you want to improve your score. We can check our current score using the prediction. If you want to save the model, as I said, you just run this thing and your model will be saved. Okay, I think you have to specify the working directory also. Let's specify it now. Working directory, okay, underscore dar plus slash. Okay, I think that's done. Yes, you can see here we have saved our best model here. If you want to reload your model, means you can use this file in order to reload your model. Now after this we will have generate captions for the image. So for this we have to create few functions in order to do this. First we have to convert the ID into a word, that is index to word. So def, I will say index to word. Here I will pass the integer and the tokenizer, because all the words we will get from the model, it will be a index. We have to transform the index into a word. So for word comma index in tokenizer dot word index dot items if index equals integer return word. I'm just iterating through all the words that are available in the tokenizer. If the index is equal to the integer we have predicted from the model, we will be returning that particular word, or else we will return none. So run this. So this is our helper function. Now here generate caption for an image. So this is the function we are going to use in order to generate the caption. So def predict caption of, we will pass the model, image, tokenizer and the max length. These are the necessary attributes we need. Now for this we have to start with the starting tag. I will call it as in-text equals the starting tag, that is start. Okay, add start tag for generation process. So for everything, if you want to predict, means you have to start with the start tag. So that's why I'm just assigning to the in text. So that is our input text. Iterate over the max length of sequence. We do have like a max length of 35. So we will iterate over that. So for I in range of max length, first we will convert that sequence, this sequence, into an integer. So encode input sequence. So for this we already covered this. I will call it as sequence equals tokenizer dot text to sequence. Okay, it's again not suggesting, I don't know what's happening. Sequences of in text of 0. So that's done. Pad the sequence, again sequence equals patch sequences of, here I am going to pass the sequence, and we have to pass the max length. So max length of 0, and here predict next word. So for this I will say y hat equals model.predict. We need 2 inputs, right? So that will be the image. So this is like a image feature we have to pass, and here we will have the sequence, and verbose equals 0. We don't have to display anything. Now this will give us a probability of 8000 columns. So we will get the index of higher probability. For that, convert or get index with high probability. I will say again y hat equals np.orgmax. So this will give us the maximum probability, or you can say it will give you the index with the maximum value. I will just pass the y hat here. We will get the index in this y hat, and convert index to word. Now we are going to call that function we have created before. Now word equals index to word of y hat, that is the integer, and we will pass the tokenizer. That's done. We will get the word. Now stop if word not found. For that, for word is none means we will break, or else we will append as input for generating the next word. So append word as input for generating next word. So here in text plus equals a space plus the predicted word, that is here. So this will be used as the next prediction. So the sequence will be updated here. Now after that, again stop if we reach end tag. So for that, if word equals, I will say end, then we will stop, break. So that's done. If the whole process completes means we will return the in text. That is our caption. So run this. Yes, it didn't throw any error. Now let's do the validation for the test data. We also need to find some blue score for this. So here I will call it as validate with test data. For this I am going to create actual comma predicted as a separate list. So actual means that is the actual captions, and the predicted means the captions we generated from the model. Now for key in tqdm of test, so that is the test data we have splitted before. Get actual caption, so that will be captions equals mapping of key. So we will get the actual caption, and after that predict the caption for image. For this I am going to say y hat or ypred equals predict caption of I'm going to pass the trained model and features of key. So I'm just passing the image features, tokenizer, and the max length. Okay, that's done. So this YPred will have a caption with a text like caption in it. Now we are going to add this captions and prediction into this actual and predicted. Before that, we will split the actual captions into multiple words, and we will have it as caption or actual caption. Actual captions equals a list caption dot split of for caption and captions. So this will generate a list with all the words in the caption, so it will be in an order, and after this we will append it actual dot append actual captions. So that's done, and after that predicted dot append ypred dot split, because we just need the words in order to do the comparison. That's why I'm just splitting it here, or you can split it in the next line itself like we have done it here. Split into words. So I will copy this. So ypred dot split, and here I'll just pass the ypred alone. Append to the list. So that's pretty much it. So this will loop all over it. Finally, calculate blue score. So this is the score we have to consider whenever we deal with text data. So this will have like the n-gram scores. So first print BLEU of 1 colon percentage F percentage. For this, I think we have to import the module corpus blue of actual comma predicted comma weights equals 1 0 0 0. So this is for 1, and similarly we have to do it for like 2 words. So the weights will be 0.5, and here also 0.5. So that's done. It will print the results. Before that we have to import it. So let's go to the top, or we can import it here itself from nltk dot translate dot blue score import corpus blue. Okay, that's done. Okay, let's run this. Okay, it's having some error. Data cardinality is ambiguous. Make sure our arrays contain the same number of samples. Okay, here we have to remove this index. We don't need it here. Let's run this, and let's run this again. Okay, it started running, but it will take a long time, I guess, for processing this 810 images. We will wait for it. Until then, we will create functions for visualizing the image and visualizing the captions. So here visualize the results. Okay. So for this, I'm going to import few modules from fill import image. So this is for loading the image. Import matplotlib.pyplot as plot. Now that's done. Now here we are going to pass the image. So I will say image name equals empty string. So here we are going to pass it, and after that image equals image dot open of os dot path dot join, or we can do it in a separate line so it will be clean. I will call it as image path equals join. Now I'm going to get it from the base directory, and here from the images folder I'm going to pass the image name. So that's done, and here I'm going to pass the image path. Let's also get an image name for this example. I will get it from the captions itself. So I think this is good. Just take a random image. If you have your own image means you can also pass this here. So currently I'm just close it, pass the JPG. Now we have loaded the image. I'll comment it, load the image. After this I will get the mappings. So I will say captions equals mapping of, okay, this I think we have to split it. So image ID equals image name dot split based on dot. I'll just get the ID and pass the ID here. So image ID. So that's done. After this I will have print. I will have like this actual. So for caption in captions, print the caption. After that we have to predict it. So I will say ypred equals predict caption of model comma features of image ID, and following by tokenizer. Okay, it's not suggesting tokenizer, and the max length. So we will predict the caption here. After this we will display the predicted. So for that again I'm going to have this predicted. Okay, that's done. Now print ypred. Finally we will plot the image, plot dot imshow of the loaded image here. We can also make this as a function. What we can see, generate caption. Yeah, I think that suits. Def generate caption of, I will pass the image name only. So this is just like a sample image we can have, and finally everything remains the same. And after this I'm going to call the function. with the image name. So this is the image name I got. Okay, now we have to wait for this to complete. So this will take some time. So we have to wait for it in order to get this score. Yeah, currently we have done it for the test validation. We are getting the blue score for 1 gram is like 0.15. Higher the score is better. For 2 we are having 0.08. I think we need to increase the number of epochs in order to get some good blue score. So this is the score. We have to use it as a metric, or else we have to use the visualization as a metrics, but this is the best one. Let's try to increase the epochs and run it for a while and compare the results, see whether it is improving or it is still the same. You have to increase this blue score. It ranges from 0 to 1, so higher is better. If you have around 0.30 or 0.40 means that is somewhat better compared to this one. So let's also visualize the result. So for this caption, okay, here you can see the generate caption. Black dog and spotted dog are fighting. So two dogs play with each other, and it's just having end. I think due to this only we are having this blue score issue. Maybe it's not having that. Let's also try out a different one to check whether it's the case. Let's go for caption. I'll take this as a ID or the whole image. Okay, and paste it here. Run this. Yes, I think it's having some issues. The girl is in the rainbow dress, and it's having the end, and it's repeating the same thing again and again. Let's tweak this thing a little bit in the generate caption. So here again in the start sequence and the end sequence, I'm like facing an issue. I'm just run this for a second time. Still it's removing this special characters. So what I'm gonna do is I'm gonna remove this special characters and have this start sequence as an entire word. And similarly, I'm going to do this for the end sequence. So this is going to be our starting tag and the ending tag. So let's run this. Let's run the mapping. So this is the actual text. After cleaning, we'll be getting like this. Now we will run the rest as it is. Okay, that's done. So here again we will just remove these start sequence, so it will be a word instead of using this special characters. So this is the example, and here we run this as it is, and again we will create the model and train the model for 20 epochs. This will take some time. And in generate captions, so this function remains the same, and only in the start sequence we will just remove these additional special characters, and even in the end sequence we will have only the word as end sequence, and we will have it after this. So this is our predict caption function, and after this we can calculate this blue score. Now for visualization it remains the same. For generate caption we will see how it looks like. So we will wait for a while until this training and the blue score are calculated. So we just give it some time. Okay, now we have completed our training for 20 epochs, and I have saved the model. And this is the blue score we have got for 1 gram. It's 0.54. It is actually a best score, because if it is greater than 0.40 means that is considered as a very good score in NLP, because we can't actually predict the exact words. It's somewhat difficult to capture the context of the sentence we are predicting. And this is for 2 grams. So here we are getting around 0.31. So this is also a good score compared to before, because we didn't have a proper starting and end tag. So after rectifying those issues, we are getting a good one. Now let's run this and let's generate the caption. Now you can see this is the actual, and this is the predicted. Two dogs are playing tug of war with the blue ball. So that is the caption we have predicted. So it's not generating additional random sequences after this. So it's actually giving us a good results. Now let's try this. Now here we have little girl in green dress, and green dress is laying in the grass with rainbow balloons in the background. Actually, it's capturing some of the things like in rainbow in the background and laying in the grass. So if you train it more, like more than 50 epochs, you may get a pretty good results compared to what we have now. Apart from this, let's generate one more. So it will be a good for comparison. So in the captions, I'll just go here. Okay, this one seems good. Instead of just getting things from the captions, you can also randomly generate this image ID and pass this as a syntax. So let's pass this. Okay, so here this is the actual, and the predicted one is man in horn backpack is displaying pictures on skis. It's actually you're predicting the skis and all. Let's run this another time. Okay, yeah, it's giving the same results, but it's actually a better compared to the actual results. So based on the actual and predicted, we are getting this blue score. So that's good. Maybe what you guys can do is run the training for more than 50 epochs in this training here, and check the results whether you are getting a higher blue score compared to what we have here. So if you got a higher scores means, please leave it in the comments, so it will be very helpful for others. And that's pretty much it, guys. We have pretty much done all the things here, extracting features and concatenating with text features like this, and we are predicting some good results. As you can able to see the results compared to the actual and the predicted ones. So other than that, if you like this video, hit the like button and don't forget to subscribe the channel for more videos. Stay tuned for the next video.